So I want us to go through this particular definition of matrix in terms of finding the determinant. Okay, we're going to use a definition that we stated in our first lesson about using cofactors to find the determinant. But before that, we need to learn something about minors and then the cofactors themselves. Okay, so the ith, jth minor of a matrix, how is it being defined? So let A be an n by n matrix, then the ijth minor denoted by, so in this lesson I'm going to denote that by m of aij, the determinant of the n by n minus 1 by n minus 1 matrix, which results from deleting the ith row and the ith column of A. What do I mean? Let me pick an example to talk about this. Okay, so if I have A to be a 2 by 2 matrix like this, then the minor A11, okay, so the minor A11 means here I is equal to what? 1, and then J is equal to 1, is the determinant that I'm going to get n minus 1 by n minus 1 determinant. Okay, so here A is 2 by 2. So n minus 1 by n minus 1 means I'm going to reduce this 2 by 1. So I'm going to get a 1 by 1 matrix, and then I'll find the determinant. And already in our first intro lesson, you know the definition of a 1 by 1 matrix, how to find the determinant. Okay, so then minor of A11 is going to be deleting the first row, right? The first row, and then deleting this first column. So the jth and then ith components, or the ith and the jth, the ith row and the jth column of the matrix. So we delete the first row and then the first column, and the matrix that will be left, that is this 6. Okay, so I have this 6, so I'm going to look for the determinant of 6. Okay, or maybe let me write it this way: determinant of the matrix 6. So this is a 1 by 1 matrix, and then we said the determinant of a 1 by 1 matrix or a scalar is just the scalar. Okay, so that is it. Now I'm going to look for the minor A12, and the minor A12 is still writing an A, and here we are still on the row 1. Okay, I is equal to 1, and then J is equal to 2. I'm going to cancel the whole of row 1 and cancel column 2. Then whatever matrix I'm left with is the determinant of that matrix, and that is -1. And the determinant of a constant is still a constant. And then I know you can see the pattern for a 2 by 2 matrix now. So the same thing, 2, 4, -1, 6. Then the M21 is going to row 2 and then column 1, right? So you have row 2 here, I is equal to 2, and J is equal to 1. So it means this is equal to the determinant of the matrix with the only entry 4, and that is equal to 4. Now the other determinant is obviously equal to 2, because that's going to be M22. So it means that the minor of A22 is going to be that -1, 6, cancel row 2 and then column 2, and I'll be left with 2. So I have that to be this. So the determinant, the minors of the 2 by 2 matrix is being given by this. Okay, so let's go to a more complicated one, and then you get to understand this, and I appreciate it. Okay, so in all cases, what I'm gonna do is I'm gonna just show you what I will cancel. So M11 means cancel the first row, okay, and then cancel, first row and first column. So first cancel every element you have there. Okay, so cancel all these. So you are deleting row 1 and column 1, and the matrix that will be left, you find that determinant of the matrix 3, 2, 2, 1. And if you remember, we first did the definition of the determinant of a 2 by 2 matrix. We said it's the product of this 2 minus the product of that, and that is going to be 3 minus 4, which is -1. I hope that makes sense, right? So the minor M11 is -1. M12 is, again, you can always try to rewrite your matrix to confirm what you're doing. Okay, 3, 2, 1. M12 means that I'm going to cancel the row 1 and then the column 2, right? So you cancel them like that, and that's going to be determinant of 2 by 2 matrix. What is left? I'm left with 4. I go to this one, I have 2 there. I come to the other one, I have 3, and then I have 1. So you just write these elements that are left as a matrix. The determinant of this is 4 times 1 minus 3 times 2. So it's become 4 minus 6, that is negative 2, right? So you go ahead and you do for all of them. And that, so determinant, the minor A13, again, I'm going to do that. So you can write it back as many as you want, as many times as you want, okay? And that we are still on row 1, cancel everything, but on column 3. So this is going to be the determinant of this matrix here that is left. And that's going to be 4 times 2, which is 8, minus 3 times 3. So that's going to be negative 1. So you can, if you want, you can actually write them, in a nicer way to present them in a, or maybe you write them in a presentable way. Okay, so what I'm doing here is just looking at it and I'll tell you the solution or the answer. Now I'm going to look for the minor 2, 1. Okay, so 2, 1 means I'm still on that same matrix. 4, 3, 2, 3, 2, 1. But here I'm going to go to the row 2 and then column 1. So I cancel all these elements, and the matrix that will be left is going to be this matrix with entries 2, 3, 2, 1. I'm going to be left with 2, 3, 2, 1. I find the determinant of this, and that is going to be 2 minus 6, which is negative 4, right? So I have negative 4 here. M22 is still the same matrix. 1, 2, 3, 4, 3, 2, 3, 2, 1. Okay. Then you delete row 2 and then column 2. So you'll be left with 1 times 1 minus 9. And so 1 times 1 minus 3 times 3. So that's 1 minus 9, which is negative 8. Okay, and you do for M23. Okay, so I'm gonna finish them right. What I'm gonna do is I'm gonna do this with just guess. Okay, so M23 means I'm canceling this row 2 and then column 3, right? So I'm going this way and I'll cancel that way. So that's going to be 1 by 2, which is 2 minus 3 times 2. So it's going to be, 2 minus 6. Okay, so you should just check it very well. 2 minus 6, which is negative 4. Now M31 is row 3, so you cancel all this row, or you delete this row, and then you go to column 1, you delete that row as well. So you'll be left with 2 times 2, which is 4 minus 9. So 4 minus 9 is negative 5. Okay, negative 5. Again, you go to M32, so you go to the same third row, then you delete this, right? So you delete this and delete that. You get 1 times 2, which is 2, minus 12, which is negative 10. Okay, so negative 10 here. And then you go to M33, which means I'm deleting this last row and then the last column. So the row 3 row, column 3, and then I'll be left with 1 times 3 minus 4 times 2. So 3 minus 8 is negative 5. Right, so these are the minors for this 3 by 3 matrix, and I hope you'll be able to do that. Let me clean this one. It's negative 2. So you had negative 2 here. This gave you negative 1. So all these are the minors of this 3 by 3 matrix. Okay, so that is how you find the minors of a matrix. And in the next lesson, we're going to talk about cofactors, and then in combination of these, you can then come up with how to find the determinant of a 3 by 3 matrix with a formal definition. Okay, see you in our next lesson.